The overview of C programming language. You know who invented C? C is actually a computer programming language which was developed in 1972 by Dennis M. Ritchie at AT&T Bell's Laboratory, USA. So Dennis Ritchie is the person who invented or who developed C, and it is in the year 1972. In the year 1988, the C programming language was standardized by ANSI committee. ANSI stands for American National Standards Institute, and that version of C is called as ANSI C. Okay. In the year 2000, the C programming language was standardized by ISO, that is International Standards Organization. That version of C is called as C99 version. Few features were added in this C99 version. Okay, so what we are discussing is ANSI C. So coming to the applications of C programming language, C programming language can be used for developing either system software or application software. So for both types of software development, we can make use of C programming language. Say for example, you can use C for designing an operating system. C can be used for designing language translators like compiler, assembler, interpreter. It can be used for designing the database. It can be used for software, that is the system utilities, software development. So these are the applications of C programming language. So for developing application software as well as system software, we can make use of C programming language. Okay, this is about a brief overview of C programming language. Now we shall see the features of C programming language. Coming to the first feature, it is simple. C programming language, it is very simple and it is easy to learn. This is one of the that is the first feature. Come to the next feature. C programming language is powerful, meaning, so in this programming language, a rich set of built-in functions and operators are supported, which you can use for writing any complex program. So that is the meaning of powerful. So rich set of built-in functions and operators are supported, using which programmer can write a complex program, can implement complex program. Okay. C is fast and efficient. So whatever the programs you have written in C, it is fast and efficient. So this is due to its variety of data types and powerful operators supported. Okay, using which we can write efficient code. C is case sensitive. So there is distinction between uppercase and lowercase. So for assume you have used a variable to hold some data. So whatever the name you have given to the variable, whatever the case you have used, you have to use the same case throughout the program. C is case sensitive, right? So there is distinction between uppercase and lowercase characters. So this is another feature of C programming language. Next, C is a high-level programming language. We already discussed the programming languages, how they are classified. So C is one of the example for high-level programming language. And what is the important feature of high-level programming language? You know, it has portability. The program written on one machine can be run without any modification or little modification. It can run on another machine. So that is the main feature or main advantage of high-level programming language. So one of the feature of C programming languages, it is a high-level language which helps which adds the feature that is portability. So that we'll list later. So C is a structured programming language or structure-oriented language, or you can say modular programming language. So what do you mean by structured programming languages? C supports different constructs. So if you want to make some decision making, or if you want to repeat some set of statements for fixed number of times, or if you want to divide the program, complex program into different sub programs, so all these are possible with C constructs supported. So we can have structure oriented programming language, that is C. So what is the advantage of going for modular approach or structured programming language? So it helps in debugging, testing and maintaining the program easily. Okay. So if there are any errors, if you are writing a single program, a lengthy program, it is very difficult to debug for errors. But if it were to be a small module where each module is performing some specific task, and debugging and testing that code will be easier. So this is the main advantage of going for modular approach. Okay. Coming to the next feature, it is syntax based. See, for each and every construct there is a fixed syntax. Okay, you have to follow that syntax to write any statement in C. If you are violating that syntax or the rule defined in this programming language, then compiler will raise an error. You know what actually a compiler is and what is the role of compiler. Here, whenever there is a violation in the rules defined in the programming language, C programming language, then compiler will detect such errors that are called as syntax errors. So remember, you have to strictly follow the syntax defined in the programming language. So C is strictly syntax based programming language. And one more feature that I've already mentioned, it is portable. That is, program written on one machine can be run on another computer without any modification or just little modification. Okay. There is one more feature of C programming language, that is, it is having an ability to extend itself. Meaning we can add our functions, our own functions or user defined functions to the C library, so that the program development time will be reduced. If same code is required in some other point, then we can just make use of the same code which is available in the C library. So this reduces the development effort, development time. Okay. So these are few features of C programming language. Let us just recall what are the features we have listed. C is simple and easy to learn. It is a powerful programming language which is having rich set of built-in functions and operators using which we can develop any complex program. C is fast and efficient. Whatever the programs written in C are fast and efficient because it is having variety of data types and powerful operators using which the program is written. C is a case-sensitive programming language. It is high-level programming language. It is syntax-based programming language. It is highly portable, meaning program written for one computer can be run on another without any modification or with little modification. And C programming language is well suited for structured programming or modular programming, meaning complex programs can be divided into set of modules, which makes the program debugging, testing and maintenance easier. Okay. One last feature is it has the ability to extend itself. That means we can add our own function to the C library. This makes the programming task simple. Okay. So these are few features of C programming language. Coming to the steps involved in execution of a C program. So assume you are given with a problem, you need to find a solution for that problem and you have to execute that to check whether you are getting the correct result. So first what we are going to do is we are going to implement that whatever the problem given using C programming language. So once the program is ready, what are the steps involved in executing that C program? So these are the steps involved. So in simple terms, we can say first you have to edit the program or create the program. Then you need to compile the program. Once compilation is done, you need to link the program with the functions that are available in the C library. Then you need to load that executable code to the main memory. And finally, you need to go for executing the program. So editing, compiling, linking, loading, and executing. So these are the phases or steps involved in execution of a C program. So what are the steps involved in execution of a C program? It is editing, compiling, linking, loading, and finally execution. Okay. So the same thing in detail you are seeing in this flowchart. First, we are going to edit the source program, that is the C program, using an important system software, that is editor. The editor is one of the system software which is used to edit the program. So once the program is created, the file will be saved with .c extension. Then the next phase is to compile that source program. So what will be the output of the compiler? That means once the compilation is done, if there are no errors, syntax errors, as I told, C is strictly syntax based programming language. If there are any syntax errors, violation of the rules defined in the programming language, then compiler will detect those errors and it will list those errors. The programmer has to go back to the program. You can see in this flowchart, if there are any syntax errors, programmer has to go back and need to edit the program, make the changes so that all those syntax errors are removed. and again the compilation process has to be undergone. So once the compilation is successful, that means object code is generated. So once the object code is generated, if there are no syntax errors, compiler will generate an object code, which is the machine code. Okay. So the next step is linker. So linker is again another system software which links the library functions from the system library to your program. Okay, and then you'll get a complete executable code. So one, the output of linker is complete executable code with the compiled code of the library functions, whatever you have used in your program. Okay, so then the next phase is to load this executable file to the main memory. So loader is the system software which is responsible for loading the executable program to the main memory, that is to the RAM memory, and then your code is ready for execution. You'll go for executing the program. So if you find any logical error or data error, so logical error means assume you wanted to perform multiplication operation, and instead of using star operator to perform multiplication, you might have used plus operator. By mistake, you might have used the statement as C is equal to A plus B. What is the operation you were intended to perform? It is multiplication, but by mistake you have given plus operator. Syntactically, the statement is correct. C is equal to A plus B semicolon. The syntactically, the C statement what you have written is correct. But the operation intended was multiplication, but you have performed addition operation. So the compiler will not be detecting such errors, logical errors. So what you have to do is you have to go back to the program and you have to make changes in your program. Then you need to again recompile it and then execute your program. So this is logical error. So there are actually three types of errors we may come across whenever we are executing any C program. One is the syntax error, which I already listed, which is which occurs whenever you are violating the rules defined in a programming language. Okay, then when you violate the syntax of a programming language, then syntax errors will be occurring, and compiler is going to detect that syntax error. Okay, coming to one more type of error, that is logical error. So you might have made mistake in your code, as I told, in the logic. So some other logic you wanted to perform, you have written some other statements to perform that operation, which is not correct, but syntactically it may be correct. So in that case, logical error occurs. So that will not be detected. Programmer has to find out such logical errors by again debugging the program. Okay. So coming to the data errors, so while giving the input, you are in the execution mode. You are executing your program by giving some input. So if you commit some mistakes while giving the input, so you wanted to perform addition, you might have given star operator. So in that case, it is just a data error. Now, how to correct that data error? You just execute. You need not compile it again. Just go for executing the program and try to give correct input. Okay. So if there are any data errors, you can simply go for giving correct input data and you can execute your program. And you can see that whether you are getting correct output for all possible inputs. Okay. So these are the steps involved in execution of a C program. So what are the steps involved? First, we need to edit the source program. Editor is the system software which is responsible for that. Once the program is ready, we need to compile that program. That source program need to be compiled to generate the object code. Compiler is the system software that is responsible for compilation. That a source program will be converted or translated into object program. If there are any syntax errors, then compilation process will be unsuccessful. Then we need to go back to the editor. Then we need to edit the program and recompile the program to generate object code. Okay. Once the object code is generated, the next step is linking. Linker is one more system software which is responsible for linking the library functions to your program available in the system library. So you'll get an expanded object code, that is executable object code, that is to be loaded to the main memory or the RAM memory. Loader is the system software which is responsible for doing that loading operation. Then you can go for executing the program. If you find any logical errors, just see, you need to go back to the editor, you need to edit the program. If there are data errors, just try giving correct input and execute the program. So those are the steps involved. So remember, in general, these simple steps: creation of the program or editing the program, compiling the program, linking the program with system library functions, loading, and finally executing the program. If anyone asks the steps involved in execution of the C program, you need to explain these 5 steps, 5 major steps: editing, compiling, linking, loading, and execution of the program. Okay, so this is about the phases involved in execution of a C program. Next, coming to the structure of a C program. Okay, so we'll first list out the sections involved in any C program. Then we shall discuss one by one what actually are going to write in each of these sections. Okay, first coming to the first section, that is documentation section. Then comes link section, then definition section, global declaration section, main function section, which includes declaration part and executable part written within pair of libraries, then subprogram section or user defined function section, where different functions we are going to write. And if it is asked to write the structure of a C program, this is what the neat diagram you need to write. This template is to be written with these sections specified: documentation, link, definition, global declaration, main function section, and subprogram section. Okay, and it is no compulsion that all these sections must be there in any C program. You can omit few sections. So depending on your requirement, you can add the sections required and then you can go for executing your program. Okay, it is not mandatory that you need to write all the sections. Which is the mandatory section in your C program is, it is the main function. Without main, your program cannot work. So this is the starting point of execution of any C program, and you need to have the main function. So one and only one function that is compulsory in any C program is the main function. Okay. So rest of the sections, depending on your requirement, you can just have it or you can just skip those sections. So now we'll see one by one what actually are going to write in each of these sections. Okay. Hope this structure or this template is clear. So these are the sections in any C program: documentation section, link section, definition section, global declaration section, main function section, and subprogram section. Okay. Coming to the documentation section. So what actually are going to write in this documentation section is, we'll be usually writing comments. So what are comments that will define? Just know that documentation section consists of set of comment lines specifying the name of the program, the author, and other details which the programmer would like to use later. So for future reference, if you want to add some information to that program, okay, so who is the author, when that particular program was created, and some details about what the program is for. Some details if you want to add at the beginning of the program, you can add it in the documentation section. So what you are going to write in the documentation section is set of comment lines. So what do you mean by comment? This is how we can define comment. Comments are non-executable statements in C. Okay, so the non-executable means compiler will just ignore the comments. So what for then you are writing the comments? It is just to improve the readability of your program. So at some complex statements you might have written or some complex code you might have implemented. So if you want to, if anyone refers to that code in future, so some information you can provide with respect to that code. So how to provide some details with respect to the code, or what for that code is written, or what that code is performing, what operation it is performing. All those things you can explain using these comments. Okay, comments are actually non-executable statements in C. Once comments are encountered, compiler will just ignore that comment. That means it is not going to generate the machine code for the comments. So compiler, what it does, it given with the source program, it translates the source program to the object code or the machine code. So if there are comments written in the program, those comment lines will be ignored by the compiler. So for comments, machine code will not be generated. The purpose of writing comment is just to improve the readability of the program. Okay, so this is about comment. This is how we can define comment. Then how we can go for writing the comments? What are the different constructs you can use to write the comments? So if you want to go for single line comment, you can write it using the syntax, or if you want to go for multi-line comment, that is also possible. So if it were to be a short description for the statement what you have written, you can go for single line comment, or else if it were to be lengthy explanation, you can go for multi-line comment. Okay, or you can use this comment concept. Say some part of the code you want to test, whichever you don't want to test, you can just comment it, so that compiler will ignore that part of the code, and whichever code you want to test, you can use, or you can test only those modules. So this is how you can make use of comment. You can just make the compiler ignore some set of statements and execute some other statement by just commenting that part of the code. Okay, so this is about the definition of comment, and as I already listed, there are two ways of writing the comments. You can go for either multi-line comment or single line comment. Multi-line comment, you can write it using these symbols. See, front slash asterisk and asterisk front slash. So this is how you are writing multi-line comment. Okay, you are using this front slash, followed by that you'll use the star operator, that is asterisk. Then you can write a set of statements, multiple lines of statements you can write, or description you can write. Then finally you're going to write star slash. So ending symbol is also required for writing multi-line comment. Are you getting? For multi-line comment, you need to use front slash asterisk. At the end you have to give asterisk front slash. So once the compiler encounters front slash asterisk, it treats whatever the statements followed by that as comment. It will ignore that statement till what it will ignore is that is the closing statement, that is symbol star front slash is encountered. Okay, it is going to ignore all those statements. So this is how we can go for writing multi-line comment. So if you want to write a short description on the statements, then you can go for single line comment. Single line comments are meant for short comment, and it can be written using double front slash. Okay, this is how you can write single line comment. Double front slash you can use. One important point you need to note with respect to comment is nesting of comments is not allowed. So you cannot write one comment within another comment. Say for example, you can see here that this is invalid to write the comment like this. Front slash asterisk, again you use front slash asterisk like this. So what happens is, whenever you are writing front slash asterisk, whatever you write after that will be ignored by the compiler till what asterisk front slash is encountered. So once asterisk front slash is encountered, then it treats that as end of the command. And once one more symbol you are finding here, asterisk front slash, so that makes the compiler raise an error. So that's why see that we are not giving any nested comments. So we cannot write comment within a comment. So remember the definition of comment, two types of comments, multi-line and single line. How we can go for multi-line comment? It is front slash asterisk. Asterisk front slash is to be given if it were to be multi-line comment to indicate end of the comment. If you are going for single line comment, only starting symbol is sufficient. Double front slash you can keep. So you can give this comment beginning of the line or at the end of the line to explain the statement. Okay. And the important point you need to remember is nesting of comments is not possible. Okay. Coming to the next section, this is about documentation section. We completed one section in the structure of a C program, that is documentation section. What you are going to write in the documentation section is the comments, set of comments we are going to write to maybe to explain the program, maybe about the author, the details of the program, the date at which it was created, etc. Okay, or you to describe about the program. Coming to the next section, that is link section. So in the link section, what we are going to write is, as I already mentioned in the previous classes, I mentioned already some built-in functions, predefined functions are available in the C programming language. They are available in the C library. Okay, So if you want to make use of that code to perform your operation, you'll be simply using those functions from the C library. So whichever function you are using, and in whichever file that particular function is defined, so that file we need to include in your program. So for including the header files, those are called as header files, which contains the declarations of all the built-in functions. You need to include that header file. So how to include and what directive you have to use to include those header files to your program, that we are going to discuss in this link section. Okay, the link section provides the instructions to the compiler to include the library functions from the header file into your program. Okay, this is what we are going to have in link section. Say for example, if you are using any built-in function that to input output function, IO functions in your program, then you have to include the header file stdio.h. Stdio stands for standard input output, and the extension of the header file is h.h. H indicates it is a header file. So in the C programming language, for depending on what operation is being performed, the built-in functions are separated into different files. We are having file which contains the functions related to IO operations. We are having file which is related to mathematical operations. Similarly, you are having files with respect to string operations. So like that, depending on the operations being performed, all the functions or which are predefined functions, they are grouped into separate files. Okay, those files we are going to call it as header files or library files. Okay, library files, they contain the declarations of all the built-in functions. So what do you mean by built-in function? They are already predefined. Okay, that means the programmer need not again go for implementing those functions. It is already been defined, and they are compiled and they are readily available in the C library. Only thing is we need to just invoke, we need to just make a call to that function to make use of those functions in your program. Okay, so that is the meaning of built-in function. Means programmer is not going to code it, it is already coded, compiled and available in the C library. That is the meaning of built-in. If you are making use of any such built-in functions in your program, then you have to include corresponding header files to your program. How to include that? So, and few header files I have listed here. The statements we'll discuss next. Okay. So just know that if I want to make use of any input-output functions in my program, say some input I want to read during execution time, or I want to display some output onto the monitor screen, then I can make use of the header file stdio.h. So if you want to make use of some built-in mathematical functions like square root you want to compute, or some sine of an angle you want to compute, or power you want to compute, that is x to the power of y you want to compute, in that case you can make use of the built-in mathematical functions. Those mathematical functions declarations you find in the header file, that is math.h. Okay, so in link section we are going to find the statements for including the files which contains the built-in functions or library functions. And the directive we are using for including, it is actually hash include, that is called as the preprocessor directive for including the header files to your program. Okay, how actually we can make use of it, that with example we'll see in a few minutes later. Okay, coming to the one more important point with respect to the C compiler is, so C compiler, it is actually, it is not just one program we can say, it is a two separate program. One is called as the preprocessor and other one is called as the translator. So compiler does two operations. C compiler, what we say in general, C compiler is meant to translate the given source program into the machine code or the object program. So this is not the only task performed by the compiler. Compiler will also act as a pre-processor. So that means before the translation process takes place, it also does some pre-processing operation. So C compiler is actually two separate programs. One is the preprocessor and other one is the translator program. So what is the task of preprocessor? The preprocessor, it scans the source program for the preprocessor directives. I just gave an example of hash include. There is one more example, hash define. Hash include, hash define, these are called as preprocessor directives. So the preprocessor will scan the program to find the preprocessor directives, and this preprocessor directive will tell the preprocessor either to include the library functions from the header file to your program or make the substitution in the code. So what do you mean by substitution in the code? We'll discuss once we go to the next section, that is definition section. For the time being, since we are discussing link section, just know that we can include the contents of the header files to your program by using the directive hash include. Okay, and what header file you want to include, that we are going to specify with some syntax that we'll see in this example. So preprocessor directive, what it does and what is the syntax of writing preprocessor directive with example, we'll see in the next slide. So what we are discussing now is the role of compiler. So compiler will do pre-processing as well as translation. Preprocessor, what that program is going to find the preprocessor directives in your program, and for that preprocessor directive, what it tells the preprocessor is to include the library functions from the header file to your program and make substitutions in the code. So what do you mean by that substitution? As I told, I'll tell you later. That means preprocessor is the software, that is the program which prepares the source code for translation. Before converting the source program to the machine code, this is what the pre-processing step that takes place. Okay. So once this is done, the pre-processing is done by the preprocessor. Next, the translator program is going to take care of translating the source code to the machine code or object code. So these are the two steps involved in compiling your source program into object program. The compiler, it is nothing but the preprocessor which does the pre-processing operation. Once it prepares the source code for translation, the translator program is going to translate the source code to the object code or machine code. Okay. And coming to the syntax of writing preprocessor directive. Preprocessor directive starts with the symbol hash, and it is used to include the library functions or built-in functions from the header file to our program, and that is done using the directive hash include. Okay, if it is asked to identify the preprocessor directive in your program, if it is starting with hash, hash include, hash define, these are the preprocessor directives which you can use in your program. So since we are discussing the link section, you need to tell the preprocessor directive used in the link section. It is hash include. You should not give any space between hash and include. Okay, hash is the starting symbol you are going to give, followed by that the directive you are using is include. Okay, and followed by that you'll be giving the header file name. So how to give the header file, you can see in these examples. See, these are few examples I've listed with respect to the header file inclusion using hash include. Hash include stdio.h. Just see what symbols we have used here to include the header file. Hash include less than and greater than symbol we have used. This within this pair of angular brackets we have written the header file. This is the name of the header file given, stdio.h. STD stands for standard, I stands for input, O stands for output, H indicates it is a header file. Okay. So any IO functions you are using, built-in IO functions which are defined in stdio.h header file, then you have to include the header file stdio.h. Similarly, any mathematical functions you are using, built-in mathematical functions in your program. I'm stressing it is functions, predefined functions if you are invoking in your program, then you have to include that respective header file. So IO related functions you can find in stdio.h header file. Mathematical functions you can see in mat.h header file. Similarly, C type, character type functions. So some functions which can perform operations on an individual character. In that case, we can make use of character type functions, which are defined in C type.h header file. Then string functions are there, built-in string functions. Those functions are defined in the header file string.h. Okay, std lib.h header file. So these are the header files which we'll be using in this course. Okay, stdio.h, math.h, that which contains mathematical functions, ctype.h, which contains character type functions, string.h header file, which contains all the built-in string related functions, stdlib.h, which stands for standard library.h header file. And this will contain some functions. Say for example, you want to terminate the program. In that case, we'll be making use of a function exit, which will terminate the program. That function you'll find in stdlib.h. And you can observe the extension of all these header files. It is h. H indicates it is a header file. So just observe the syntax of having the file inclusions. Hash include is the preprocessor directive we are using to include respective header files. For IO functions, stdio.h. For mathematical functions, math.h we can include within pair of angular brackets, ctype.h, string.h, and stdlib.h header file we can use. And this is one way of writing the syntax. Angular brackets we are using. That means it is going to search, the compiler is going to search, the preprocessor you can say, or the compiler, it is going to search for these header files in the standard directories. Okay, so from where it can include the contents of these header files to your program. So these are the few example file inclusions which you can use in your program. Okay, so this is about the link section. So what we have discussed with respect to link section. So in link section, we are going to write preprocessor directive hash include. What is the purpose of hash include preprocessor directive? Once the preprocessor encounters hash include, what it does is it goes for including the contents of this header file to your source program. Okay, that is the operation performed by the preprocessor. We just listed two tasks with respect to the preprocessor. The preprocessor, it scans your program to find the preprocessor directive. If it were to be hash include, it includes the content of the header file to your program. If it were to be definition, hash define directive we are using, that we'll discuss in the next section, where it is going to do the macro substitution. So what do you mean by that macro substitution? That we'll see in the next slide. Okay, coming to this definition section. The definition section defines all symbolic constants. So say for example, you can see hash define is the directive we are using, preprocessor directive, for defining the symbolic constants. Say for example, you are computing area of a circle. You know the formula to compute area of circle, it is pi r square. There is no pi symbol in C. You need to define, or you need to assign the value for pi. So how to assign the value for pi? If you want to directly use this constant 3.1412 in your formula, you can use it. Or to improve the readability of the program, you can name this constant. So how to name this constant? We can give the symbolic name that is called as a macro. Okay. Here, how to do that? By using the directive hash define. We are going to specify the preprocessor directive hash define. Then you'll give a space. You'll give the symbolic name pi space. You'll give the value you want to assign to this pi. The assigning meaning, wherever you are using pi in your program, okay, uh, that pi symbolic name will be replaced with the constant what you are defining in the hash definition statement. Okay, this is what called as macro substitution. So preprocessor, if it is hash include directive, it includes the content of the header file to your program. And if it were to be hash define directive encountered, then it searches for this symbolic name in your program, throughout your program. That symbolic name will be replaced with this constant what you have assigned. So wherever I'll use pi in my program, the pi name will be replaced with actual constant. So this is called as macro substitution or macro expansion. This is what the role of preprocessor. So this is one more step you can specify while executing any C program. So far, we have listed creating, compiling, linking, loading, and execution. In addition to this, in compilation, one more subphase you can tell, that is pre-processing. Okay, where the preprocessor is going to do this macro substitution and file inclusion. So these two steps are taken care by the preprocessor. Okay, this is about symbolic constant. And what is the advantage of having symbolic constant is one advantage is it improves the readability of the program. Instead of directly writing 3.1412, it is actually the pi value. We can specify that symbolic name using hash defined directive. And one more advantage is you're giving unusually symbolic constants will write in uppercase. So this is not the rule. It is just the common convention we follow to write the symbolic constant. Reason just to separate it from the variable, normal variables with the symbolic constant. We'll go for writing the symbolic constant in uppercase. You can also write it in lowercase. As I told, it is not a rule. It is the common convention we follow to distinguish between normal variables and the symbolic constant. And as I told about one advantage, it improves the readability of the program. One more advantage of having symbolic constant is assume you are writing directly the constant at different points in your program. Okay, assume for your program you need some maximum limit or maximum range you want to specify, maximum and minimum value you want to specify, that you have given at different points in your program. At some point in future, those values you want to change, that value may get changed. So if you want to make changes, what you have to do is you need to go to those each of those points in your program, and you have to edit those values. So this is cumbersome, right? So if it is a complex program you have written, and at different points in the program, if you have used that constant, and in future you wanted to edit that constant, then you need to scan each and every line. You have to find out wherever you have used that constant, and you have to go for modifying that value. So this is bit difficult task. Instead, if you had used this hash defined process preprocessor directive, and if you have assigned the value to the symbolic constant, then it is very easy. You can just go to this the beginning of the line, beginning of your program where hash define is given. That value, whatever you have assigned, this value can be changed to the new value. So what the preprocessor will do, wherever the symbolic name is used, that will be replaced with the symbolic constant. You need not manually go to each and every point to substitute or to change or to edit that value. So this is one more important advantage of symbolic constant. And it is no rule that the symbolic constant has to be defined at the beginning of your program. So before accessing that particular symbolic name, you should see that it is defined in the it is defined using hash defined directive. Common convention we follow is we are going to use this hash defined statement before the main function. Okay, this is the common convention we follow. Nowhere you see the examples where hash define is given within the main function. What I am telling is you can also write hash define within the main function also. Before using this pi for in your formula, see that the hash define statement is given. But normally what we'll do is the file inclusions using hash include and hash definitions using hash define directive. All these will write it before the main function. This is the common structure we are following to write the C program. Okay, so this is about hash define. Hope till this it is clear. In today's class, this is what we have discussed. We saw, I just discussed with the overview of the C programming language, who invented C, what are the applications of C. Then we discussed the features of C programming language. After that, we saw different phases involved in executing a C program. The main important steps you need to list out: it is pre-processing, compilation, then compilation or the translation, then we need to link, then load, and finally execute. So then I gave you the structure of a C program with different sections. What are those sections we listed? It is documentation section, link section, definition section, global declaration section, main function section, and sub-program section. In these sections, we just discussed two sections, that is the documentation section, link section, and one more section just now we discussed, that is definitions section. So what you write in the documentation section, it is the comment lines for improving the readability of the program. Then what you actually are writing in the link section, it is hash include directive to include the content of the header file to your program, and hash that is in the definition section you are going to write hash define directive. Okay, so this is for defining the symbolic constants. And one more few more examples I've given since it is timer. Okay, let us just quickly go through this also. A few other examples of hash define max 100. That means wherever you are using the symbolic name max, it will be replaced with 100. Say I want to give symbolic name for opening and closing flower brace, I can give like this: hash define begin space flower brace, opening flower brace, hash define end closing flower brace. One example for this, one complete program I have written here. Hash include stdio.h. This is the link section I've used. Hash, these are in the definition section. You can see hash define begin opening flower brace, hash define end closing flower brace. Then int main is given, and see. In place of writing opening flower brace for a function, I've used the symbolic name as begin, that is called as the macro. Then I've written the statement printf good morning, and I've given return 0, and I've given end. So what is the purpose of writing printf, return 0? All those things we'll discuss in detail in the later classes. For the time being, I've given one simple complete program which is using this hash define and hash include directive. So what preprocessor will do is, wherever you are using symbolic name in your program, say I've used begin and end, begin will be replaced with this opening flower brace, and end will be replaced with closing flower brace. So like this, it is not just for the constant. You can use this definition section for replacing any statement. You can make use of this symbolic constant. And actually preprocessor directives is a huge topic. There are lots of conditional preprocessor directives and all. Since it is out of the scope of the syllabus, we are not at all discussing those directives. What you need to know at this point is just these two directives: hash included, hash define preprocessor directives. Okay, so this is about the definition section. In the next class, we'll discuss the rest sections of the C program. I think today's class it is sufficient.